Hi guys, Miss Griffin. We're looking at Unit 3, Skill 3B. So it's an extension on 3A where we were solving those 3x3 systems. And now we're going to solve some that are just a little bit harder. Okay, harder in the fact that you have to multiply initially one or more equations by some number, not just by a negative in order to get a variable to cancel. So if you recall, your first step is to write your solution off to the side by using your calculator. So I'm going to write the calculator steps to find solution. In calculator, you're going to go to menu, option 3, option 2 for solving linear equations, and then you're going to type in your equations. So you're going to pause your video if you have a calculator with you. Maybe you're watching it in the classroom right now and you could use a calculator. If not, then just follow along with me. We're going to write these down. Your calculator spits this out for you, just as I showed in the last video. And if you recall, these are in the order of the variables in terms of alphabetical order. So this goes X, then Y, and then Z. Second step you want to take is to actually label your equations. So we've got A here, B, and C. And remember that we always use capital letters, even though that C looks really teeny tiny. Next step is to look at your variables and their coefficients. So I have a 4x, a -2, and a +5. I could probably eliminate the equation A and equation B with x's pretty easily, but it's going to be a little tougher to eliminate with equation C because that 5 doesn't go nicely into 4 or into 2 or vice versa. Okay, so we'll pause on that for a second. I'm noticing that my y's, I have a 1y here and a -1y, so I'm just going to put those coefficients in there real quick. If you don't mind doing that, that might be helpful for us later. So we have a +1, a +4, and a -1. That seems like it might be pretty easy to work with to eliminate y's, because I can just multiply equation A by a -4 in order to cancel it with +4. And same thing down here, I can take this and multiply it by a +4 in order to cancel here. Or I can cancel with A and C quickly, +1, -1. Okay, so that would eliminate y's for us very quickly. Let's just take a look at z's. Maybe z's are easier, who knows? We've got -3, +2, and -7. Definitely not easier. So we're going to stick with y's for a second. The reason it's not easier is because those numbers, all the equations would need to be multiplied by something in order to get them to cancel. So we're going to eliminate y, and we're going to do this by probably starting with equation A plus C, because as I mentioned before, A and C can cancel very easily on those y terms, just the way that they are. We don't have to multiply by anything, because they are the same number and opposite signs for those coefficients. So I have 4x plus 1y minus 3z equals -6, and then we have 5x minus 1y minus 7z equals -19. So if you recall, what we do is we just add straight down. Okay, so 5 plus 4 is 9x. 1y minus 1y cancels. -3 take away -7 is -10z. And then summing the numbers on the right gives us -25. And now we call this equation D. And we're going to circle it because we're going to come back to it later. Next up, we need to add another pair of equations. And so what I'm going to do is take the two equations with opposite signs, that's B and C, on the y's. We have a +4 and a -1, but C needs to be a -4, not a -1. What we're going to want to do is take equation C and multiply it by a 4. So we've got equation B plus 4 times equation C. So I'm actually going to show that work right here. Multiply equation C by 4. It's going to look a little messy, but at least I'm doing each term individually, and so it will be easy for me to write it out afterwards. So writing out equation B first, we have -2x plus 4y plus 2z equals +38. And then for C, again, we're multiplying by 4, so 5 times 4 gives us a +20x, then a -4y, and that's a good thing because, again, we want those y's to cancel, a -28z, and then -19 times 4 is -76. So our next step here is to eliminate y's by adding straight down. Okay, so we've got Negative 2 plus, that looks like a horrible 20. It looks like a 26. Let me just fix that up real quick. This is 20. Okay, so negative 2 plus 20 gives us positive 18x. Y's cancel. Minus 26z equals negative 38. Okay, again, adding straight down is all I did. And then this will be equation E. So we're just going alphabetically when we label equations. You could call it equation star or chicken or nickel or whatever you want to call it, but I'm just going to use letters. Okay? Next up, we want to look at equations D and E to now eliminate either the variable x or the variable z. So what we're going to do is, again, look at our coefficients. So we have a 9x and a positive 18. 9 and 18 are related to one another. All you have to do is take 9 and multiply it by 2 and you get 18. So it looks like x's might be pretty easy to eliminate. We do have to negate one of them, so if I just multiply this by negative 2, it should cancel with positive 18. However, let's look at z's because maybe they're easier. We've got negative 10 and negative 26. Definitely still not easier. Z's are just giving us a hard time today. So what we said we wanted to do was take d and multiply it by a negative 2 on all parts. So here now we have negative 2 times d, which will get added with equation E. Okay, so we're going to show this work. We got to write down what we get when we multiply. We got to write down equation E and add straight down afterwards. So when I multiply, again, that's coming from here, we have negative 18x plus 20z equals 50. And then equation E stays exactly the same. 18x minus 26z equals negative 38. So from here, when I add straight down, x's cancel. Then we have negative 6z equals positive 12. 50 take away 38 is positive 12. Divide by negative 6. And we have z equals negative 2. And before I box it in, I want to come back to my solution and ask myself, did it work out? Heck yes, it did. Z equals negative 2. All right, so now from here, what we're going to do is plug z into equation D or E. Totally your choice. I'm just going to say D because it comes first in the alphabet. Okay, so we have that 9x minus 10 times our z value, which is negative 2, and then still equal to negative 25. So again, all I did was pull equation D and plug z into it. All right, so 9x plus 20 equals negative 25. This is just simple solving, so I'm going to go through it very quickly. X equals negative 5 is what I'm finding. When I come back to my solution, woohoo, we did it again. All right, we're doing a great job so far. Now we got to plug z and x into equation either A, B, or C. Totally your choice again. So now we're going to go plug. You don't have to write this piece down, but this is just for me teaching you. Plug x and z into, wow, this is not writing every time I try to write, into, I'm going to do equation A. All right, so we've got that 4 times the x value, which we found was negative 5, plus 1y, we still don't know y, and then minus 3 times the z value, which is negative 2, equals negative 6. All right, so again, simple solving. Negative 20 plus 1y plus 6 equals negative 6. When I combine these like terms, we get 1y minus 14 equals negative 6. Add the 14 and we get y equals positive 8. When I look back at my solution, way back up here in the tippy top, y equals positive 8. Boom. Step 6 is just to write your solution as your final answer in the order of x, then y, and then z. So we have negative 5, comma, 8, comma, negative 2. Okay, and this becomes our final answer, but you have to have all of this work in order to support it. Must show all work. All right, so we're going to move on to the next example and see what we got going on here. Okay, so we're looking at example 2 here. And it says solve the following system of equations, and then we've got these equations here. And I noticed that this third equation is looking a little goofy. So the first thing you want to do is get all your variables to one side if they're not already there. So I've got x over here. I need to add 7y. And then this positive 7 can just stay right where it is. So this is going to be rewritten as x plus 7y. Notice that there's no z, so I'm going to put plus 0z. And then equals positive 7. So when I relabel these equations, this is A, B, and C, and then of course I have to find my solution. So you're gonna, if you have a calculator, take a minute, type in those steps, just as we talked about in example 1, find out what your x, y, and z are, to type in these equations on your calculator and get your solution. And when I do that, I get 0, 1, -7. So those are the answers we're looking for as we solve this. So again, of course, the first process that we're going to take, or first step we're going to take, is to look at your variables. So we've got a -3, a positive 7, and then of course the 1 that's sitting here. I'm actually going to go through and put all those 1s in there that we need when there's no coefficient. Okay, so -3, 7, and 1. It looks like I'd probably need to multiply 2 equations there by a number. So let's take a look at our next variable, and that's the y's. We have -1, -1, and positive 7. That seems pretty easy because I can change those 1s to 7s, no problem, just by multiplying. And then looking at z's, oops, I missed a coefficient of 1 here. So looking at z's, we have 1, -2, and 0. Okay, so we could also probably eliminate z's pretty easily. So I'm going to choose to just stick with eliminating y's, and then we'll probably be able to eliminate z's afterwards. Okay? So to do that, step 1, notice how the steps are not numbered here. This is on our own now. Step 1, we are going to first, again, eliminate y. So if I want to eliminate y, I need to get equation A and B to have 7s in it, because C has a 7y. So let's take A and multiply it by 7 and add it with C. Okay, so 7A plus C. So take every single piece in A and multiply it by 7. So that's a -21x minus 7y plus 7z equals -56. And then C can stay exactly the same way. So positive 1x plus 7y plus 0z equals 7. And of course, we're going to add straight down. So we've got -20x, y's cancel, plus 7z equals -49. And this here becomes equation D. And then, of course, we're going to circle it because we'll come back to it later. I want to reiterate the fact that I could have started by eliminating z's, or I could have eliminated x's first, right? So you can eliminate whatever variable you choose to, and so your whole work here could be very different from mine. However, you want to choose the easiest variable to eliminate just to make your life easier, and that for me is this y in this case. Okay, so now I'm moving on to step number 2, where I still want to eliminate y, so I'm going to take equation B and change this 1y that's sitting right here and multiply it by 7. Okay, so I need 7 times b plus c. All right, so 7 times equation b, that's going to give me 49x minus 7y minus 14z equals 13 times 7, which is going to be 91. And then equation C gets written just as it is, 1x plus 7y plus 0z equals 7. And again, just add straight down. All right, so this gives me 50y, or 50x. I don't know why I always do that. I always say the wrong variable. 50x. And then negative 14 plus 0 is negative 14z equals 98. And this is equation E. Circle that up so we can move on to step 3. Step 3 is where we use equation D and E, these two equations, in order to eliminate a variable. So if I look at x's right here, I'm going to go back to using my highlighter. Looking at x's, we have a negative 20 and a positive 50. Not so easy. We can multiply each of them in order to make like a 100x. That's not too bad, but I have to multiply two equations in that instance. Whereas if I look at the z's, I have a 7z and a negative 14z. I can very easily turn this 7z into a 14 by multiplying by 2. I want it to be a positive 14 because this one's already a negative 14. Okay, so we're going to multiply this whole equation, every piece of it, by 2. So it's 2 times equation D plus equation E. All right, so that gives me negative 40x plus 14z equals negative 98. And then 50x minus 14z equals positive 98. Add them straight down, and we get positive 10x, z's cancel, equals 0. That seems a little weird, right? But just keep solving. Divide by 10, and we get x equals 0 divided by 10 is just 0. And when I look back at this, x is supposed to be 0, so we've done a great job so far. Step 4, you're going to plug x into either equation D or E. Again, totally your choice. Choose whatever one's easier for you. So I'm just going to take and plug it into D. Seems to be my go-to. Then you've got negative 20 times the x value, which was 0, as we found, and then plus 7z equals negative 49. So again, simple solving, we've got 0 here, plus 7z equals negative 49. 0 is just kind of gone. Divide by 7, and we have z equals negative 7 is what I'm finding. When I look back, woohoo, we did it right. Z is negative 7. All right, so moving on to step 5, we've got to take it and plug one of those, or both of those solutions into one of the equations from up top. All right, so we're going to go here to probably equation A, just because it's the easiest one, or it comes first in the alphabet, whatever you prefer. Plug x and z into equation A. And again, you could do it into A or B or C or whatever one you want to from back up top. So we have negative 3 times the x value minus 1y plus 1 times the z value equals negative 8. All right, so let's solve this real quick. Just trying to color code. I didn't realize I didn't change the color for z. All right, so we've got 0 minus 1y minus 7 equals negative 8. 0 is just gone, so negative 1y, I can add 7 to both sides, equals negative 1. Divide by negative 1, and we get y equals positive 1. So again, before I box it in, I want to check back up top and make sure that y should be 1, and that's what we just found. Okay, so great, we're doing fantastic. Isn't it so nice to know the answer ahead of time so you can check your answer as you work? So again, order it x, y, then z. So we've got 0, 1, negative 7. Final answer. Flip it over so we can see some special cases, and then we've got an extra guided practice if you need it. All right, so there's a couple special cases. If you are solving a set pair of equations, maybe you've already eliminated z. Already. It could be any variable that you've eliminated already, but you're here with two variables, and you're starting to add straight down, and you get these to cancel, these to cancel, and these to cancel. So what we're saying is that if we find 0 equals 0, that means that there are infinite number of solutions. Okay, so when you go to write your solution, you're not going to go for curly brackets. You're going to instead say solution is infinite solutions. Important thing to remember here is that if you get something that is 0 equals 0, you have infinite number of solutions. Another super special case is if we're solving, ooh, that did not stay with it. If we're solving and we have, again, eliminated a variable already, we add straight down, these cancel, so there's 0 on the left side, equals some number. So it's not just 0 equals 24, this is not the case in every situation. It's the fact that here we were supposed to say 0 equals 24, but this is not mathematically true. Right? 0 does not, in fact, equal 4. So this is where we would reject it and essentially say that there is no solution. So if you end up with 0 equals a number other than 0, then no solution. Okay, so infinite solutions is when you have 0 equals 0. 0 equals some other number is that there's no solution. Okay, so then if you need the next page, if you need more practice with 3x3 systems, move to the next page. All right, so this is only if you need it. It's extra guided practice. Extra, okay? So if you don't need it, don't listen. Move right to your practice problems next class. If you do need it, follow along with me. All right, so again, first step, A, B, C. Second step, solution, X, comma, Y, comma, Z. And in order to find it in your calculator, you're going to hit Menu, and you're going to go to option 3 and then option 2. And when you do that, you get a screen that looks like this. It says Lin Solve, because you're solving a linear pair of equations, or set of equations in this case. Then it has these boxes you have to fill in with your equations, comma, and then it tells you X, comma, Y, comma, Z is the order in which it's going to come out. Okay, so then once you've done that, you type in your equations with the equal sign, and then you hit enter. Okay, so now we're going to actually do this process. So I want to, again, reiterate the fact that highlighting your coefficients is super helpful. We have 3a, -2, and 3a. Okay, so those, it seems like we could just multiply a couple equations by a number to get the same coefficient with opposite signs. We have 3, we have 2, and we have +6. So we could definitely deal with b's as well, get everything to be a positive or a -6. And then c's here, we've got -4, +4, and +5. So it doesn't look like there's a very strong starting point here, right? Because I could easily eliminate C with choice A and B, but then I have to multiply both equations by something, 2 equations by something in order to get them to be a common number. I have to multiply 2 equations here to get them to be 6. I have to multiply 2 equations, well, probably all 3 equations here to get them to become 6. So I don't know necessarily what the easier option is. I'm going to go with first eliminating C's. Okay, because this is just what I'm thinking might be the easiest thing. And I just realized as I'm saying those letters that we said our equation gives us x, y's, and z's because that's what you should be typing into your calculator, not a's, b's, and c's. So this will be a, b, and c in the end. It's just in the alphabetical order listed again as x, y, and z because in your equation you need to type x's, y's, and z's. Okay, so that's an important step that I didn't talk about. For our solution, I found -4, 3, and -6 in my calculator. So we're going to refer back to that in just a few minutes. So as I mentioned, I think that we're going to try to eliminate C first. You'll notice if you ever get your hands on a notes answer key that I actually did the answer key by eliminating B first. So again, you can do this in different ways. Like this is totally your choice, but this is what I'm going to go with for the video. Okay, so when I am looking at step number 1, I want to figure out how to eliminate C, the variable. Okay, so I can do that easily with adding A plus B because currently they have the same coefficient but opposite signs. So this is going to be 3A plus 3B minus 4C equals 21. And then negative 2A plus 2B plus 4C equals negative 10. And of course we're going to add straight down. So this is 1A plus 5B, C's cancel, equals positive 11, and this becomes equation D. Step 2, eliminate C's again, but now I might have to multiply something by a number. So I'm going to go with taking 5 times A and adding it with 4 times C. This is going to help me get a negative 20C plus 20C. Okay, so again, I'm looking at these C variables here. Opposite signs, so I don't have to multiply by a negative, but I do have to get them to a common number, and that number for me is going to be 20. So I multiply it by what it's missing to make it to 20. Okay, so we have 5 times A. So, all right, look in here. We've got 15A plus 15B minus 20C. Again, I'm multiplying by 5. So that's all I'm doing. Equals 105. And then C's I have to multiply by 4. Okay, so that's 12A plus 24B plus 20C. Great, so these C's are going to cancel. I can see it already. See it. We're canceling C's. Get it? Negative 24 times 4, so that gives us a negative 96. And then again, add straight down. Okay, so this is going to be 27A plus 39B, C's cancel, equals positive 9, which now gives us equation E. Circle it up, and then we're going to move on to step 3 where we have to eliminate a new variable this time. So step 3, let's try to eliminate, well, we got to figure that out actually. Eliminate blank. All right, so going back to my highlighters, we have a coefficient of 1A and 27 with the A. It seems like it'd be pretty easy to take and multiply this A by a negative 27 to get it to cancel. However, I'm going to compare options with B's. We have a 5B and a 39B. Holy moly, no thank you. Right? You'd have to multiply them to get a common number, both equations. Whereas this one I only have to multiply equation D by negative 27 all across the board. So we're going to eliminate variable A, multiply each piece by negative 27. Oh, 27, not Z7. And so when I do that, I get a negative 27A, a negative 135B, again by multiplying by negative 27, and then equals negative 297. I can leave equation E just the way that it is, so it's 27A plus 39B equals positive 9. So from here, we're going to add, A's cancel purposely. Negative 135 plus 39 is negative 96B. And then negative 297 plus 9 more is negative 288. I can solve this for B by dividing, and we find B equals positive 3. And when I go back to my solution, remember B is the same as Y. B is in fact 3. Okay. Step number 4, plug in B. Plug B into either equation A or equation D. Or not D or A, it's D or E, sorry. Plug into either D or E. All right, so we've got, let's see, 1 times A plus 5 times the B value, which is 3, and then equals 11. All right, so 1A, or A, plus 15 equals 11. Subtract away 15 and we get A equals -4. When I look back at my solution, A is in fact -4 because it matches up with whatever the X was. Fifth step is to plug A and B into equation A or B or C. All right, so I'm going to go with A. And when I zoom out here, we've got 3 times the A value, which we found was -4. And then plus 3 times the B value, which we found was +3. Minus 4C equals 21. So when I take a minute to solve this one, we've got -12 plus 9 minus 4C equals 21. So a -3 minus 4C equals 21. Add 3. -4C equals 24. C, when I divide, should be -6. So when I go back up to my paper at the top, C is in fact -6. Okay, and so when I box this in, then I'm ready to go to step 6, writing my solution. Remember, it's in the format of A, then B, then C, just like it'd be X, Y, Z. So we've got -4, 3, -6. And again, I can't stress enough how important it is that you are checking your answers with the solution as you go. Check answers with solution as you work. All right, go ahead and get working on your practice problems if you are at school. If not, you can enjoy the rest of your evening and then come ready to work the next class, okay? All right, goodbye.